Hello and welcome to the last part of solving systems of equations. This week we're working on eliminations, which secretly is the easiest way to solve a system of equations. You've just jumped through the giant hurdle of figuring out substitution, and so this is going to be a tool that you can use that's a little bit easier than substitution. I'm going to try and explain it first by talking about property of equality and reminding you why that works, and then I'm going to go through and teach you how to solve a systems of equation using elimination with addition. So let's go ahead and get started. All right, so property of equality and why it works. I want to remind you of property of equality here because I think this is going to help you understand why any manipulation of an equation is okay, and the reason that we can use manipulation of an equation to solve our problems is because we're keeping the same proportions. So I was thinking about how to tell you this, and I was like in the middle of getting my kid a snack, and I thought to myself, okay, so she really likes granola bars, and let's say that I had a box of granola bars, and I'll just call it X here. So the box of granola bars has 8 granola bars in it. And so X is equal to 8, X being the box of granola bars. So what if I wanted to buy 3 boxes of granola bars? As in, what if I multiplied this side by 3 and I had 3 boxes of granola bars? Well, if I'd have to multiply this side by 3 and I would have 24 granola bars. So essentially, 1 box of granola bars is 8, and then 3 boxes of granola bars would have 24. So it doesn't matter that I multiplied both sides by 3 because we know that each box of granola bars has 8, and so 3 boxes just has 3 times as many. We could also do something like this, back to the original granola bars. If I had 1 box of granola bars equals 8, and then I added 1 to both sides, so let's say I added 1 here and 1 here, then I would have 1 box of granola bars plus 1 individual granola bar is equal to 9 granola bars. So again, I'm not changing the proportion of the equation or the value of what X is, I'm just simply manipulating it if I were to add or multiply. And this way it works the same with division or subtraction. So property of equality, as a reminder, is if you do something to one side, you must do it to the other, and it doesn't change the equation proportion, it just simply changes the quantity, so you can multiply, divide, add, or subtract. But it's still even if you do it to both sides. So let's talk about this problem I found in the book. This is on page 281, and this is just a really good story problem, I think, to illustrate, first of all, why you would even use standard form to figure out a way to solve a problem, and then this really lends itself well to the elimination using addition that we're trying to figure out. So this says 2 trains, train A and train B, weigh a total of 312 tons. So we know that added together, these weights, which are unknown to us now, equal 312. Train A is heavier than train B. If we were to take the difference, their weight, it would be 170 tons. So we would do train A, which is heavier, minus the weight of train B, and we would get 170. So we're saying use elimination to solve the systems of equations to find the weight of each train. So again, this is new, but you will probably very easily pick it up. I'm going to go ahead and show you that now. So remember, we have the weight of train A plus the weight of train B is equal to 312 pounds. And then we have the weight of train A minus the weight of train B is equal to 170 pounds. So notice that we have positive A and positive B added together equaling 312, and then positive A plus negative B, or positive A minus B, equals 170. So what we're going to do, I'm going to show you the elimination trick, I guess, and then I'm going to explain to you how it works. So if I were to draw a line here and just pretend for a second that this is one giant addition problem, and of course I'm going to draw a line through my equal sign. I'm going to put a plus here. I have A plus A is going to be equal to 2A. B plus negative B actually cancels out to be 0, so I'm not going to write anything, equals 312 plus 170 equals 482. So all of a sudden we have, using just one move, which is adding these two equations together, we've gotten rid of B, and now we have one variable remaining. 2A is equal to 482. Now I know that I can simply divide both sides by 2 to get A alone, because 2 times a, the opposite operation, is divide, and then I have a equals 241. So right now I already have the answer to a. And you might be thinking to yourself, whoa, how is that possible? How does that even work? Well, remember property of equality back earlier where I said you can multiply, divide, add, or subtract anything to either side and it will still keep the proportion of the equation the same. So check it out. You have added a minus b to this part here. And on this side, you've added 170 to this part here. But also, existing in this problem is the fact that a minus b is equivalent mathematically to 170. So essentially, you've added 170 to both sides, or you could look at it by you've added a minus b to both sides, and so you're keeping the equation equal, so 2a equals 482 is actually equivalent to a plus b equals 312. I know this is a lot to wrap your mind around, because it's a lot for me to wrap my mind around and then explain, but essentially all you did here was property of equality of addition, and you've essentially eliminated b. Now, it does seem like a trick, but it definitely does work. So now I have a equals 241, and I want to go ahead and go back to my, I'll just take the first equation. I got a plus b is equal to 312. Well, a is actually 241, right? So 241 plus b is equal to 312. Let's just go ahead and do the subtraction here. 241 minus 241 here. So we have b is equal to 71. All right, so our answers is a is 241 and b is 71. Now let's go ahead and just check and see if that works. So like I said, a 241, b 71. Let's go ahead and plug it in to check. 241 plus 71. I'm just going to do my addition vertically because it's easier for me to do while I'm teaching live. So this is going to be 11, 312, so that one checks out. And then 241 minus 71, so 1 minus 1 is 0, and then 24 minus 7 is going to be sorry about that, I had a kid walking in. 24 minus 7 is 17, so I have 170 and 312. And so our original equation was a plus b is equal to 312. A minus b is equal to 170, and so it works out. So knowing that this method is there and it's incredibly easy, let's go ahead and attack another problem and see if we can do the same thing. So here we go. This is actually example 1. It's 5-4 in the textbook. So let's go ahead and just use our same strategy here. I got 2x plus y is equal to 8, and I got 4x minus y is equal to 4. Now, again, I'm going to go ahead and change my color here. Pretend this is one big addition problem, and I'm going to put a plus here. And so 2x plus 4x is going to be 6x. And then y plus negative y actually cancels out. 8 plus 4 is 12. Now I can go ahead and just get x alone by dividing both sides by 6. And I have x is equal to 2. All right, so I got my x. Now I just got to plug x back in to get y. So I have here 2. And then we remember x is actually also 2. Teaching with a stylus can sometimes be difficult, so I appreciate that you guys deal with it. Okay, so 2 times 2 is going to be 4 plus y is equal to 8. Subtract 4 on both sides, and y is equal to 4. So my answer here is 2, 4. Let's just go ahead and make sure that that works in our equation. So I have an answer of 2, 4, and I'm just plugging it in to check. So I have 2 multiplied by 2 plus 4 is equal to 8, and so this becomes 4 plus 4 is equal to 8. That works. And then I have 4 and x is going to be 2. Ooh, trying to go back and forth is kind of tricky. Okay, 4 times 2 minus y is 4. It should be equal to 4. So 4 times 2 is 8, minus 4 is equal to 4. So yeah, our answer is 2, 4. All right, I'm going to stop the video here and post some practice problems, and then I will be back with an answer key video. Thank you.